In our first film, we talked about the fact that there are many obvious contradictions in the world history, which have not yet received a reasonable scientific explanation. And many questions are raised by the chronology, which was created and almost completed in the 16th and 17th centuries by the historian and philosopher Joseph Scaliger and the theologian and the Jesuit Dionysius Petavius. Since ancient times and to this day, the entire history of mankind is clearly dated. In numerous historical and archaeological reference books, you can find the answer to almost any question. Museums around the world store unique exhibits, witnesses of bygone eras. Among them, there is hardly a single one whose plate will say, "Origin unknown," or "Age unknown." All these objects are pedantically grouped and laid out in a strict chronological order. But why did the scientists come to the conclusion that, for example, this jug belongs to the 5th century BC, and this one to the 8th century AD? It is generally accepted that the methods of determining the age of ancient objects are well checked, and most importantly, very reliable. In this film, we will try to figure out whether this is really true. Is the world history really based on rigorous scientific evidence? It all starts with excavation. The greatest interest of archaeologists is, of course, the ancient settlements. It is there that the history of the development of one or another people is concentrated. Any place where people have lived for a long time keeps the traces of their stay. Garbage is accumulated, old buildings are destroyed, and new ones are erected in their place. In almost every city, which has a long, centuries-old history, you can find such a building. It seems that it went deep into the ground under its own weight. In fact, the reason is different. Garbage was thrown out of houses, bones, worn shoes and clothes were thrown out, damaged items of the household, broken dishes. These remnants were covered with dust, people and animals on their feet brought dirt, and the level of the earth gradually rose. Thus, for many centuries, a high archaeological deposit was formed. Archaeologists cannot yet determine at what speed these deposits accumulate. In each particular case, this speed is different. But archaeologists can determine which deposit was formed earlier, which one later. The study and description of archaeological deposits is called stratigraphy. To do this, an excavation is made or an exposed area of the coast or ravine is selected. In order to clearly see the sequence of all deposits, the area is evenly and clearly cleaned. But how to find out in which year or which century a particular deposit was formed? As a rule, each of them stores some items in itself. These may be the remains of wooden buildings, coins, ceramics, decorations, written documents and much more. With their help, each cultural deposit is dated. And to determine the age of the finds themselves, physical, chemical, biological and other scientific methods are used. We will consider the main ones and find out whether it is always possible to obtain an accurate dating of a historical artifact with their help. Dating by analogy is where it all starts. As soon as archaeologists discover an ancient artifact, they try to determine the age of the finds, household works, weapons, decorations. But the fact is that in ancient manual production, even the same master could not make two absolutely identical things. Therefore, much more often they come across not identical, but similar things. Hence the name of the method of dating by analogs. It works like this. For example, a ring was found in Novgorod. According to certain signs, scientists come to the conclusion that it was made in the 12th century. After some time, archaeologists find another ring in the Urals mountains, which is very similar to the one in Novgorod, and they conclude that it should also be dated to the 12th century. But why? Simply because they look alike.
This is a very crude method. We are talking about the fact that they are approximately of the same age, but we come across some kind of trouble here. This may be a completely random repetition. We are just talking about the fact that it is similar, but it may have been made much earlier or later. We are mistaken in this analogy.
Moreover, what one archaeologist considers similar seems different to another. As a result, it turns out that the similarity and the difference between the things that are dated by this method are determined subjectively. Another very important point. Precious, cult and simply memorable things could be stored for a very long time, passing from generation to generation. And if an object is found in an old, destroyed house, which archaeologists date back to the 12th century, it does not mean that the house was built in the 12th century. Most likely, this only means that some of the residents simply kept this ancient thing. Conclusion. The method of dating by analogies is very subjective, does not have a strict scientific basis, does not allow determining not only the exact but even the approximate age of the finds. It is believed that the cultural deposit or burial can be dated, if ancient coins were found there. What does it mean? For example, archaeologists dig up some kind of town. None of the found items tells them anything about the age of this ancient settlement. But if the coins are found, then there is a chance of determining the age of this archaeological site. After all, it is the coins that should contain the necessary information. We are used to seeing the name of the country, the portrait of the ruler or founder of the state, and the date of issue on modern currency bills and coins. But the fact is that the date of minting on the coinage is mandatory in all countries only the last 250 to 300 years. In antiquity and the Middle Ages, it did not matter whether there was a date on the coin or not. Therefore, the ancient coins on which the year of minting is indicated are very rare. Certainly, there are exceptions. The newsreel has preserved a unique moment for us. Archaeologists pour out the contents of the clay amphora on the table. These are the coins of the Bosporan kingdom, found in the Crimea. On the coins there are not only the names of the rulers, but also the years of release. It was on the basis of this finding that the list of the Bosporan kings was compiled, whose names had never been mentioned before. But such finds are an exception, not a rule. However, archaeologists argue that the age of the coins can be determined by other signs. For example, if there is an image of the emperor or king on it, his name, then this is piece of cake. It is known when Charles I, Henry II, or Ivan IV the Terrible ruled. But is it really that simple? There are examples in history, when many years after death of the ruler, His image remained a symbol for descendants, which they depicted, including on coins.
The history of coinage has so many examples of deviation from some standards that, of course, there have been such cases. For example, you can say that the coins with the name of Tsar Fyodor Ivanovich were minted at the end of the time of troubles in Russia. Because for certain political forces, the name of this Tsar was a kind of a symbol of resistance. Although the Tsar has been dead for more than 15 years or so.
It is even more difficult with antique coins. At that time, a huge number of imitation coins were minted. For example, the mint of the Roman Empire minted its legal coins with the image of the reigning emperor. Then the coins were found not only in all corners of the empire, but also in the adjacent territories, which were in the sphere of political and economic interests of Rome. The tribes that inhabited these lands did not have their own, so to speak, national money. So they imitated Roman money and made copies of the emperor's coins. As a rule, the tribes imitated the most common coins. This means that if they got the most coins with the image of the Emperor Trajan, they minted imitations of these coins. And it did not matter whether Trajan was alive or dead. A century could have passed after his death, and imitation coins still continued to be minted. Or another example, the famous Greek coin tetradrachm depicting Alexander the Great. For many years, the imitations of this Athenian coin were minted wherever it was common. Along the entire coast of the Black Sea, in Asia Minor, in North Africa, in the Middle East. Having discovered such a coin in the cultural deposit of an ancient city, it will be difficult to determine the age of the coin itself and the age of this deposit, and the portrait of the emperor will not help here again.
The portrait of Alexander the Great imitating the image of Heracles was minted on his coins. That is, there was a portrait resemblance, but, nevertheless, it was not yet customary to place a portrait of a real person, even such as Alexander the Great. But these coins were also issued not only by the mints, on the territory of this great Macedonian empire, but also in many adjacent lands. That is, we come to the conclusion that the portrait of the sovereign does not always indicate that this coin was minted on the territory of his state during his reign.
But money is not only coins. For example, when excavating ancient Russian settlements, archaeologists often find not coins, but silver bars. It is believed that the value of silver coins of that time was low, since coined silver contained a large amount of impurities. Therefore, few coins were minted, and small bars of pure silver were in use. But a bar does not have any dating signs at all. No dates, no images, no features of stamping. All scientists can do is roughly estimate the period when the bar was used. But it is, of course, impossible to date the cultural deposit using it. But there are also coins without any clear dating signs. They lack not only dates, but also inscriptions and portraits of rulers. Instead, ancient coins often feature images of animals, birds, flowers, and even insects. But without dates and names, these coins are just metal objects. It is difficult to establish not only the year of minting, but even which coin was issued earlier, which later. In some cases, by analyzing the alloy, it is possible to determine the place where the metal was mined. But it is impossible to determine the age of the coin in this way. Despite all the difficulties of applying this dating method, archaeologists believe that finding any coin is important.
It cannot be said that the dating of the archaeological deposit by coins is the best and exceptional method. Everything is always relative. But no archaeologist will neglect the data provided by the coins.
Conclusion. The method of dating by coins cannot be used if the coins found in the excavations do not have clear dating features. Such signs are absent in most ancient coins. They themselves need to be studied and dated. In the old days, as today, clay was the most available material, including for production of household utensils. Pots, plates, jugs were made in large quantities. Therefore, it is not surprising that the main material of almost all archaeological artifacts is huge mass of ceramics. That is, fired clay products. To determine the age of clay products, scientists try to use the archaeomagnetic dating. Any clay contains smallest particles of iron, so it is able to be magnetized. But as soon as the clay is burned, that is, heated at a temperature of over 600 degrees, the magnetic field in it seems to freeze. The finished clay product remembers magnitude and direction of the magnetic field of the Earth territory where it was made. But after hundreds and even thousands of years, it is very difficult to find out the exact age of, for example, this jug. To do this, it is not enough to know how the planet's magnetic field has changed over centuries. It is necessary to determine how it has changed in each particular region, but even this is not enough. Additional information about the jug itself is needed. How it stood in the kiln during firing, whether the kiln was warmed up evenly, whether there were iron objects near the kiln or forge. And these are just some of the questions to which it is almost impossible to find answers.
Archaeomagnetic dating on the Earth's magnetic field is very unreliable. It is very unstable. And so some amateurs try to use this dating method, but it is not competitive.
Conclusion. The archaeomagnetic dating is interesting theoretically, but it is difficult to apply in practice. It is almost impossible to determine the exact date. Time was once measured with an hourglass. This simple device could be found in every wealthy family. The bulbs of the hourglass are marked with divisions that show how much time has passed. 5 minutes, 10, 15. Scientists thought, is it possible, by the same principle, to find out at what rate sedimentary deposits accumulated on the planet? This idea quickly gained popularity around the world. But numerous studies have yielded disappointing results. The fact is that different sediments accumulate at different rates. Sand accumulates at a rate of several centimeters per year, and clay at 10 centimeters per millennium. Moreover, each climate zone has its own rate of sediment accumulation. The same sediment in the tropics and in the Arctic will accumulate differently. For example, it is known that in Egypt, buildings built under Pharaoh Ramses II are buried under a 3-meter layer of sand. It is generally accepted that the pharaoh reigned about 3,000 years ago. This means that a meter-long layer of sand has been deposited here for 1,000 years. But in some areas of Europe over the same 1,000 years, only 3 centimeters of sediment accumulated. And in the mouths of the Liman in the south of Ukraine, 3 centimeters of sediment is deposited annually. Another example. Scientists have found that limestone accumulates rather slowly, several tens of centimeters per 1,000 years. But on Paracel Island, Spanish coins of the 15th century were found in a limestone reef at a depth of 1.5 meters. And if scientists are convinced that the coins were made in the 15th century, then this means only one thing. The initial calculation was erroneous, and limestones can grow by 30 centimeters not in 1,000, but in 100 years.
Recently, this method is almost never used. It is very unreliable. You see, binding to certain completely archaeological antiquities is so conditional that it cannot withstand competition with radiocarbon dating or something else.
Conclusion. The sedimentary dating can only be used to determine the age of modern sediment deposits. It practically does not work for dating ancient deposits. Scientists consider it a great success if an archaeological site contains many wooden fragments. Because it becomes possible to determine the age of an object with an accuracy of up to a year, and to determine the century is not at all difficult. How? Using dendrochronology dating. Let's see if this is really the case. Dendrochronology is a method of dating archaeological finds and ancient objects. Dendrochronology arose at the end of the 19th, beginning of the 20th century at the junction of 3 sciences, geography, history and biology. And in 1920, the American scientist Andrew Ellicott Douglas first used this method to date the ruins of Indian settlements in the southwestern United States. The dendrochronological method is based on the law of nature, according to which every year the thickness of a tree increases by 1 annual ring. Tree rings grow unevenly over the years. If the year is warm and sunny and there is enough rainfall, then the tree grows quickly. The ring that grows this year will be wide. If the year is cold and dry, the ring will be smaller. It is believed that in trees of the same species growing in the same place and climate, the thickness of the annual rings is approximately the same. But how, using this method, to find out when the found wooden building was made? To do this, you need to build and compare 2 graphs. One is a tree ring graph of logs from the building. The other is a reference graph for a specific tree species. A dendrochronologist takes a cut of a fossil tree and places it under a digital microscope. To get the most accurate graph possible, tree rings are examined along 4 radii. To obtain a clear picture of the rings, the cut is cleaned and processed with chalk. A dendrochronologist counts the number of rings, determines their thickness, and uses a computer program to build a dendrochronological graph. In the same way, a graph is made for all logs taken from the building. Now we need to build a reference graph. To build the longest possible scale, you first need to examine the oldest representative of your species. To do this, a living tree does not need to be cut down. It is enough to take a small sample, which is called a test core. A specialist dendrochronologist, using a special drill, drills a small hole in the tree and takes out this sample. The core is placed under a digital microscope, and on the monitor we see a clear pattern of annual rings. The beginning of the reference dendrochronological scale has been completed. And here comes the first problem. The fact is that, for example, in European forests, Trees grow no more than 400 years, a maximum of 500. So, on the basis of living trees, we can stretch our scale from today into the past only up to year 1500 AD. It is possible to draw the scale further only with the help of dead wood, that is, withered trees. At the dead wood, it is possible to make a saw cut. It is examined in the same way as the previous samples. Compare the graph of the dead wood with the graph of the living tree. We find the so-called stitching, that is, the same pattern of rings. And we see when the tree was born and when it died. We extend our reference scale by about 500 years ago. We get the year 1000 AD. At this stage, the second problem appears. And how to build a scale further? At one time, scientists from all European countries faced this problem. For different tree species, oak, boxwood, cedar, pine, juniper, it was possible to build a continuous scale only up to the 1000th year of the Common Era. Then there are voids.
Appear gaps or hiatus, a Greek word which we use when we do not know exactly what was here. Then we need to accumulate data in order to fill it. What is scientific work in general? In scientific work, you are constantly faced with these very problems that require addition of materials, search for this material, and analysis of this material, or the development of new methods that will allow more accurate dating of those materials that are already known.
It turns out that it is possible to determine the exact age of any wooden finds in Europe only if the trees were cut down no later than the 1000th year of the Common Era. American dendrochronology finds itself in better position. Their trees live up to 4,500 years. For example, sequoia or pilus. A sample of only one living tree allows you to build a scale for 4,000 years in the past. But with this scale, it is impossible to date the wooden finds of Europe and Asia. But it was here that civilization was born and developed. It is here that the main historical monuments of mankind are concentrated. We were lucky with our sample. These trees were cut down around the middle of the 16th century. And if the samples were much older, the dendrochronology method would hardly come in handy. But this is not the only difficulty in applying dendrochronology. In order to determine the age of a burial, it is not enough to find one log in it. Having sent it for research, archaeologists will only know the type of tree and how many years it has been growing. A serious dendrochronological study requires several dozen logs. And far from every excavation you can find such a quantity of wood. Therefore, if the log found in the tomb of the pharaoh is dated by historians as some millennium BC, then they do this not as a result of dendrochronological research, but simply on the basis of historical considerations. How the tree was processed and stored is also an important factor. When processing a tree, the constructors cut off its outer layer, and these are several rings, and today it is impossible to find out how many exactly.
Here you take a log and there should be the so-called last ring, the outer ring. If you don't have this outer ring, then you say that there is no such thing. The last ring dates back to, say, 1200 AD, but let's say they cut off some rings. And you assume that, according to some data, these are about 20 rings, that is, roughly speaking, 1220 AD. But you have no right to say that this is 1220 AD. You say that the last ring dates back to 1200 AD.
And if not 20 rings, but 100, 100 rings is a whole century. A great success in the application of the dendrochronological method in archaeology is the dating of the ancient pavements of Veliki Novgorod, Novgorod the Great. In this city, 28 layers of pavements were found, laid one on top of the other. And these are not some half-decayed remnants, but 28 layers of perfectly preserved pine logs. Examining their growth rings, scientists came to the conclusion that this so-called puff pastry pie was built by the Novgorod people for 550 years. It is generally accepted that Veliki Novgorod was founded in the 10th century, which means that the first layer of the pie was laid immediately after the formation of the settlement. Veliki Novgorod was founded in swamps, and in swampy areas it was simply impossible to do without wooden pavements. We add 550 years and get the middle of the 15th century. It is the 15th century that archaeologists date the uppermost flooring. Does this mean that starting from the 16th century, the townspeople stopped laying new pavements and until the advent of asphalt, that is, until the 20th century, they trampled in the mud in the streets? The archaeologist's explanation that all wooden floorings made in Veliki Novgorod after the 15th century rotted without a trace does not sound very convincing. Obviously, the lower layers of the Novgorod pie are located in swampy soil, and in a swamp, as you know, organic matter deteriorates very slowly. But why did these physical laws only apply to pavements made earlier than the 15th century? Although archaeologists consider this topic closed, questions remain. 1 out of 2. Either the dendrochronological dating can be wrong by 500 years or more, or the city known to us as Veliki Novgorod was founded much later than is commonly thought, and the date of its birth should be considered not the 10th, but the 15th century? Conclusion. Dendrochronology allows getting more or less accurate dating only if a certain number of requirements are met. Most archaeological sites do not meet all these requirements. To date, radiocarbon dating is considered the primary method for determining the age of archaeological finds. This method of dating is used to date objects and materials of biological origin. The method was proposed by the American physicist Willard Libby in 1947. We emphasize that the radiocarbon dating is used to determine the age of only organic objects. With it, you can date the remains of animals, wood, fabric, paper. The operating principle of this method is as follows. All biological organisms contain carbon. In the Earth's atmosphere, carbon is present in the form of stable isotopes C12 and C13 and the radioactive isotope C14. The isotope C14 is constantly formed in the atmosphere due to the influence of radiation. The main source of radiation is cosmic rays. It is estimated that about 7 kilograms of radiocarbon is produced and decayed annually in the Earth's atmosphere. Formed at an altitude of 15 kilometers, radiocarbon is oxidized by oxygen and dispersed throughout the atmosphere. Then it gets into plants. Animals eat plants and radiocarbon is passed on to them. A person eats plants and animals, and along with them, radiocarbon enters the human body. After the death of a living organism, no more carbon enters it and carbon exchange stops. This means that stable carbon remains in the remnants, while radioactive carbon gradually decreases. To find out how many years have passed since the death of an organism, it is necessary to measure the amount of radiocarbon remaining in it. Let's see how it works in practice. These shots were taken in Ethiopia. They were provided to us by scientists from the Severtsov Institute of Ecology and Evolution. In this African country, scientists were part of an archaeological expedition. During the excavations, the remains of an antelope were found. To determine how much time has passed since the death of the animal, scientists took a fragment of the antelope's skull, specifically a horn, for research. This is the laboratory of the Institute in Moscow. Scientists carefully examine the sample that was brought and prepare its fragments for analysis. To get rid of possible impurities, the fragments are placed in glassware and treated with hydrochloric acid. After being processed, the sample is sintered in a special oven and analysis begins. All this operation takes place here at such an installation. Pumps are used to create a vacuum in all flasks. A sintered sample is placed in this flask, and distilled water is poured into it, which will be released drop by drop into the flask with the sample. A reaction has started. A colorless gas, acetylene, is released from the sample. To collect it, you need flasks called trap. They are frozen with liquid nitrogen. First, acetylene falls into the first trap, then into the second trap. While the reaction is occurring in the flask with the sample, it is necessary to connect the catalyst to the apparatus. A bottle containing a catalyst is connected to the installation and placed in a special oven. In the flask containing the sample, the foam dissipated, indicating that the reaction is complete. All acetylene is frozen in the first trap. While it is defrosting, it is necessary to connect an activated carbon container to the installation. After thawing, acetylene from the second trap passes through washing liquid composed of anhydrone and alkali, and is collected in a bottle containing activated carbon. The washing liquid cleans the gas of possible impurities, and the alkali and anhydrone remove water vapor. Acetylene gradually accumulates in this trap. Then it will fall onto the hot catalyst, which is removed from the stove and placed in a flask with water. Benzene is formed at the bottom. The last trap is connected, and the catalyst itself is once again placed in the furnace. Here in this trap is the very benzene that had to be obtained. After several hours in the refrigerator, benzene is carefully introduced into the container, which is then placed in the measuring apparatus. This calculating machine should calculate the radiocarbon age of our sample. We entered the data given to us by the machine into a computer program that converted the radiocarbon age into a calendar age. Here is the result of our research. The African antelope lived from 790 to 510 BC. It seems that everything is quite simple and understandable, but is the dating obtained always true? Are there any mistakes?
The fact is that rather complex measuring systems are used in the course of radiocarbon dating, and their operation, such as the operation of photomultipliers, may not be entirely stable. Therefore, the probability of an error exists and it is not small.
Other factors also affect the accuracy of dating, primarily changes in the concentration of radiocarbon in the atmosphere. The isotope C14 is formed in the atmosphere under the influence of cosmic rays, but the rate at which it accumulates has never been constant. It is affected, for example, by the sun's activity. When it is increased, fewer cosmic rays reach the Earth's surface. Conversely, when it is lowered, more do. Also, the formation of radiocarbon is affected by the intensity of the Earth's magnetic field, which is not constant either. Additionally, another important point, when determining the radiocarbon age of any biological object, the so-called bomb pulse must be taken into account. Indeed, in the 1950s of the last century, above-ground nuclear tests were carried out. Because of this, the concentration of radiocarbon in the atmosphere has nearly doubled. There is a group of organisms whose dating shows the so-called imaginary radiocarbon age. This means that radiocarbon dating will show that, for example, the age of any marine organism is much older than it actually is. The fact is that the bottom sediments of the world's oceans contain a lot of radiocarbon. These sediments have been lying at the bottom for an enormous number of years, and the half-life of radiocarbon is only 5.5 thousand years. So in terms of radiocarbon dating, this radiocarbon is very old, even dead. But it keeps infiltrating the organisms of all marine life and sometimes ages them for thousands of years. There are also difficulties in dating wooden structures. After all, the radiocarbon dating determines only the time when a tree was cut down, and not the time when people constructed something from it.
For example, in Arctic conditions, it often happens that a tree thrown by the sea onto land, the so-called driftwood, which is widely used by local residents for various household needs, both as fuel and mainly for buildings. This tree could stay on the shore for quite a long time. It can be several hundred years old before it can be included in the archaeological site. The same piece of wood can be used by the inhabitants multiple times, and the dating obtained from such a piece of wood does not tell us about when the artifact was formed. Rather, it tells us about the time of death of the wood.
The situation is no better with the dating of written sources. Museum workers often ask radiocarbon laboratories to date museum exhibits, including ancient scrolls. A very small fragment is needed for dating, but museum staff, as a rule, does not know the whole history of the storage of these ancient written documents, namely, who, when and with what processed them in order to save them from rodents, insects and various microorganisms. Therefore, the error in determining the age of these objects is quite substantial. Obviously, scientists have computer programs in their arsenal that can determine the age of samples, taking into account all of the aforementioned factors, as well as recipes for cleaning organic materials from unnecessary impurities. Yet, mistakes do happen.
There are several studies available. These studies were carried out in large radiocarbon laboratories where a large number of samples were dated. So, they showed that approximately 1 in 10 of the radiocarbon datings turns out to be, let's say, significantly different from their apparently real age.
Every 10th dating obtained in the best laboratories in the world is erroneous. This means that at least 10% of the dates that scientists use to date ancient objects are wrong. And they continue to use them.
There are now hundreds of thousands of radiocarbon dates around the world. In fact, this is our main support. Here, at a depth of up to 40 to 45,000 years, this is the most important method of dating. Yes, with some caveats, yes, with certain restrictions, but we didn't have anything for this. Nothing. Therefore, we are obliged to build our conclusions only on this. And we do so.
Scientists often say that when determining the age of a biological object, they never rely on just one single analysis. That only the coincidence of several measurements can guarantee accurate dating. In 1988, perhaps the most famous radiocarbon dating was carried out. In the laboratories of radiocarbon dating of the Arizona State University in the USA, the University of Oxford in the UK, and Swiss Federal Institute of Technology in Zurich, Switzerland, scientists independently examined fragments of a certain canvas, using a blind method. That is, the researchers did not know what kind of samples had come to them for dating. These were pieces of the Holy Shroud, a 4-meter linen in which, according to legend, Joseph of Arimathea wrapped the body of Jesus Christ after his suffering and death on the cross. Since 1578, the shroud has been kept in a special reliquary in the Cathedral of St. John the Baptist in Turin. Therefore, today it is known as the Shroud of Turin. On April 21, 1988, under the supervision of Cardinal Anastasio Balestrero, Archbishop of Turin, and invited experts, a piece of about 7 square centimeters was cut from the shroud, divided into 3 parts before being sent for research. All 3 laboratories independently dated the fragments of the canvas to the 12th–14th century AD. But according to the chronology accepted today, Christ was born 2,000 years ago. It turns out that in this case, radiocarbon dating did not answer the question about the age of the shroud, but instead gave rise to new questions. Is the Turin shroud really a forgery, or can radiocarbon dating errors be hundreds or even thousands of years? Is the shroud the original? But then in what century did Christ live? The controversy has not ceased for 20 years. Conclusion. Radiocarbon dating can only be used to analyze objects of organic origin. Dating errors can reach up to 2,000 years. For dating historical artifacts that are hundreds of thousands years old, such an error is acceptable, but when dating objects that are only 2,000 to 4,000 years old, such an error is unacceptable. So, we looked at the main methods that scientists use to date historical artifacts, and found that none of them can be completely trusted. Unfortunately, the imperfection of all these methods leads to a large number of errors. Many of them have already become dogmas. On their basis, more and more generations of historians continue to build erroneous versions of the events of world history.
Everyone makes mistakes, and archaeologists make mistakes too, after all, because when we dig, you think we know everything for sure. Of course not. Let's hope that our physicists, chemists, or biologists will come up with new methods. But so far, I see nothing of the kind, except that it is necessary to improve those methods and accumulate new materials that will clarify what we have been talking about, gaps. We have many gaps, but we fill them in.
In the 20th century, historians and archaeologists came to the conclusion that over the past 200 to 300 years, the vast majority of ancient monuments had begun to deteriorate at a faster rate than in previous centuries and even millennia. For example, large pieces began to break off from the Egyptian Sphinx, which had allegedly been standing for 5,000 years. In fact, scientists cannot say exactly how quickly the monuments were being destroyed 1,000 or even 500 years ago, because they have only been monitored constantly for the last 2 centuries. Some scientists believe that modern industry is responsible for the destruction of monuments, while others believe that climate change and environmental pollution are the culprits. However, all these assumptions do not have a solid scientific basis, as no wide international study has been conducted. Most likely, the fact is that none of these monuments are very ancient, and they are being destroyed at a completely natural rate. To determine the age of this entire historical heritage, it is necessary to use not only the usual, but also other new dating methods. Learn about new mathematical methods of dating historical events, and how mathematicians are using them to reconstruct history. In our next film, Truth Can Be Calculated.